Choose your fighter.
Lightning inspired. Fight.
All right, so 6 was 3 multiplied what? By BC. All right, anybody remember what I said to work this out? What to do? You multiply. Yeah, yes. All right, I'm hearing some distorted voice.
So I think you said 3 times everything in B only,
Mm-hmm.
then times by C.
Very good. Or
Or you said B times C.
10 times
Then,
everything. Right.
yeah,
Very
by
good.
3.
I like this one. You know, I kind of like this one. All right. So, did anybody try work this out? Did you guys try to work this out? All right. Sounds like a resounding no.
Yes, sir.
Oh, somebody tried it. Okay, cool. Um. All right. So go ahead.
I have a 0. You need an answer or we're working it out?
No, we're gonna demonstrate how we got the numbers.
Okay. So I
Row by
have
column.
0, 1. So 0 times 5
Hmm?
plus negative 3 times 0
Mm-hmm. Go with the other side now.
yeah, 0 times 5
Mm-hmm.
plus negative 3 times negative 6.
Right. Very good. Don't you know?
Then I have 1 times 5
Mm-hmm.
plus negative 2 times 0
Mm-hmm.
1 times 5 plus negative 2 times negative 6.
All right. Great. Who wants to take on the challenge of? Thank you, Miss. I need somebody else to participate.
You're welcome.
Tell me how they arrive at those how you get the final numerical value. Anybody want to contribute? Or what goes here and that kind of thing. No? Nobody?
So
All right.
would you?
Okay. You gonna try?
Yes, sir.
All right, cool. Thank you. Go ahead.
So for the top one, so you're gonna have 5 plus.
You mean this top one here?
Yes, sir.
You sure?
2 on the
Yeah,
5.
but times 0 times 5 plus the negative 3 times 0 to get that one first.
What's 0
What is
times?
0?
What is 0 times 5?
No 0, sir?
Right. What's negative 3 times 0?
Negative 0, sir.
Yeah,
Just
right.
0,
So the whole thing would have been what? 0.
0.
All right. And then this will be also 0, not true? All right. I'm gonna multiply two negative. You get a what? A positive.
Positive.
3 6s, 18. What about this one?
So that would be 5, sir.
Mm-hmm.
Plus 0, so that is 5.
Plus 5, right? That gone.
Mm-hmm.
So yeah, we have this one left to do.
5
All right, 5. Mm-hmm.
and 12 plus 12
Mm-hmm. Because two negative here, positive, and
positive.
we get what? 17. So that's the answer. Well, that's the answer for B times what? C. All right.
There's
Everyone?
0 over
Oh,
5 and 18
mm-hmm.
over
Of
17.
17. Right. Thank you very much. Is everybody following?
Sir, the answer would be
Oh, hold on,
8.
hold on. Are you? Is everybody that's hold on? Give me a second. Is there anybody not following? Is everybody following? All right, cool. So it sounds as if
Sir, I
mhm.
roll by column.
Like me mix up there, man.
Where is 3 BC? Could you explain what they are for me? Is B times C?
Right. So it's B times C. And when I multiply B times C, we get this matrix 0, 5, 18, 17.
Okay.
That's B times C, you know. That's what we just worked with a while ago.
Okay.
It's these, and that. So
Mhm.
all these numbers should have gone into what? This little matrix here.
Okay.
All right. And then when you get all those numbers and you multiply by what? By 3. All right.
Mhm.
And you're done.
Okay.
All right.
Okay, sir.
All right. I believe somebody was making a contribution. Do you still want to go ahead?
No, sir.
All right. Thank you. So it's 0, 5, 18, 17. All right. But then no, guess what? No.
Sir, you're going times the 3.
Right. Hey guys, this is what I did a while ago. You said to get rid of the box. You know what I have to do? Stop share and share again, and just go. That's what I did. So anytime it pop up again, I just do that. Stop share and share again. It just vanish until it come back again. It's really annoying though. I hope it doesn't bother you that much. So then no, it's going to be we're gonna multiply everything by 3, right? So what we do is multiply everything inside by 3. So we have 3 times 0, 3 times 18, 3, 3 times, all right, it's gonna be with 3 times what's that, 5, and 3 times 17. And then no, you just get the answer, and that's it. You're on a home run now. You're on a home stretch. So what's 3 times 0? 0.
0,
What's 3 5s?
15,
And what's 3 times 18?
54,
54.
What's 3 times 17?
51.
51. And that's the answer.
Okay, sir.
That's 3 multiplied by BC. All right.
I was a bit puzzled, sir, but I did it the other way, but it's the same answer I got.
Okay. What did you do? You said 3 multiplied by B,
Yes.
and then you
When I
multiply
get that answer, I multiply
by C. Right. Very good. Right.
Okay.
No, that's a very excellent way you did it, because then you realize that if you had multiplied 3 times C and then multiply everything, you're not get it wrong.
Okay.
So I'm saying, right? But I don't know. I just prefer. I think students will see this better. So B times C and S.
Okay.
All right. So let's look at the last part. Did anybody try the last part? All right. So the last part is B.
Sir, follow it for me, please.
Okay, hold on. Just give me 1 minute. Let me just write the question and done. B subtract 2C square. So this is the question. All right, now what you're gonna do is you're gonna work out.
Gonna work C square first,
Right,
sir.
right. Very good. All right, let me put this as bullet points. So we'll work out C square first. What next?
Then you times by 2. C square is times 2.
Right. Times it by 2. Oh, by the way. What is C square, by the way? How do you work out C square?
Sir, what I did, C is 5, 5. C would be equal to 5, 5, 0, negative 6. So I said 5 times 5 is 25. 0 times 0, 0. 5 times 5 is 25, and negative 6 times negative 6 would be 36. Then I times it by 2.
No, that would be wrong.
Okay.
All right, and I also did mention to you that that's not how you're supposed to do it. So C square is actually C times C. That's how you go.
Okay.
Yeah. So and what is C times C? C times C would be the matrix, like this multiplied by itself again. Not true. Yeah.
Oh, okay.
Yeah.
Okay. Okay, understood.
What you said to me is a common error here that students make. So it's nothing. Yeah.
Understood, sir.
And even when sometimes you make the correction, people still do the wrong thing. So it's actually not saying you do, don't get me wrong. All right. So basically, that's what you're gonna work out.
Right.
All right. And when it get this answer now, then it times it by what? By 2. And then now you just put B in front of it.
and minus it.
and minus it. On your way.
Okay.
All right. Anybody try this? All right. I'm going to give you 7 minutes to work this. Multiply C times C. Put 2 in front of it, multiply. Then you subtract B from 2C squared.
I tried it first.
Sir, the B must in front or behind.
All right. Have to be in front.
Okay.
Have to be in front.
Because this says B minus.
Right. If you put it on the right hand side, you're going to get it wrong.
Okay.
Good question.
Yes, sir.
All right. 5 minutes. All right. All right. So hold on. Okay, guys. Um, or any. Sorry. Give me a second. Oops. Let me tell you now. Is to be a teacher in this pandemic here, online platform, you have to be skilled, especially with math. It's like if I was teaching history or biology or English, I just sit and talk, you know. But boy, this whole bugger technical thing. I mean, math by itself, face to face, is very technical for me to even explain and write on the board, much less to do online. But so far, I think I'm doing a pretty good job in terms of presenting the information to you pretty well. All right, because I realize that my excellent my handwriting, my crypto handwriting, not working at all. So I rather with this. It's a bit tedious, but at least you're able to see it it's presentable. All right, any takers for C square?
Yes, sir.
All right, go ahead quickly.
You want to answer everything, sir. All right, so it's going to be 5 times 5.
All right, hold on. You know what would be nice if everybody same thing. Because boy, upa time, you know. Just give me the final answer.
I have
What?
25 over
Mm-hmm.
0
Don't say
negative.
all right, don't say over because you might be saying something missing. You might be, don't just a 25 and what 0.
Yes, sir. And then negative 5 and then 36.
All right, is she correct,
Sir,
class?
sir, but you have to minus the b from that.
No man, we're just working out C square.
Okay,
Is she correct?
Yes,
that's what I
sir.
have, sir.
All right. Okay. So very good. All right. Um. Then no. Then no. We're going to know? Multiply now two. Two times what? Times everything in here, not true?
Yes, sir.
Right. All right. All right. So it's pretty straightforward. All right. Who wants to give this a shot or
So
a kill? Boy, my maths becomes violent, not true? Take a shot or a kill. All right.
so
What's
it would
that?
be
Mm-hmm.
50, negative 10,
Mm-hmm.
and 0,
Mm-hmm.
and 72.
Very good. All right. And then no, we're at the last step. This
Right.
is gonna be this is gonna be this is gonna be B subtract this, not true. The 50 and the thing, not true.
Yes, sir.
Right. Hey, a whole power is it? A holy power it is. A holy power. But guess what? You're bringing out all the theories, all the concepts. Do you realize that? Right. And by the way, how we add and subtract is different from how we multiply, not true? How do we subtract matrix? Anybody remembers? Entry by corresponding what? Entry. All right. So this is going to be 0 subtract 50. Remember, we're not multiplying.
Yes, sir.
So we can't say row by column, right? Remember, we're not multiplying.
So it will be negative 50.
Right, which would be negative 50. Very good. And that's negative 3 subtract 10. Everybody see that?
Like, go keep on positive.
Yeah. Hold on there. Hold on a second. So subtract 10, right? And these two negative will give you a positive.
So root
And you have
30.
1 minus 0. Negative 2 subtract 72. All right. And then no, we're on our way to Zion. Is that so?
Yes, sir.
Or Babylon, wherever? Which way? Where you guys want to go? Zion or Babylon? So that's negative 50, right? And that's 1. You owe Mr. Brown and you owe Mr. Brown. Not true. And that's negative 74. Okay, what's happening right here? That's a plus, not true?
Yes, sir.
7,
So
sir.
that's negative 3 plus 10. What is negative 3 plus 10?
7.
Positive 7. You owe Mr. Brown $3. All right?
I got him.
And your mother gives you what? $10. Mr. Brown, take him $3. You're gonna have change.
7.
Right. So that's 7. So so that's 7. Or in class, so you can use a calculator. It's right here, so you can use a calculator. I'm telling you. So you don't have to stress yourself about all them something. And this is our final answer, ladies and gentlemen.
Yeah.
Anybody got this, by the way? Like, actually got the final outcome?
Yes, sir.
Whoa!
Yes, sir.
Very good. 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 Awesome. If you don't get it in the means in the world, just means a boy, just go and practice. All right. We're gonna move on. All right. We're gonna look at what we call the determinant of a matrix. All right. So class, can I make a suggestion to you in regards to your SBAs? Is it possible we could do some private meetings over the weekend rather than using class time? Like, for example, say Kristen. I say, okay, Kristen's group, can you join me via Zoom? Is that possible? Because I really don't want to waste class time.
Yes, sir. Yes, sir.
All right. So over the weekend, I will dedicate a time slot. Or you tell me when you're available. Or you and your groupmates can decide on a time when you guys are available and when I'm available. All right. So some of you probably available Sunday or Saturday. All right. Because what happened, what's going to happen is that I am going to be focusing on one group while everybody else is toggling. Then when I finish with that group, I move on to the other group, and then you go and wait. It's a lot of time running. All right. So we're going to look at what we call the determinant of a 2 by 2 matrix. All right. In CXC, they specify that it's a 2 by 2.
Sir, before you go on, bring down back the screen a little.
All right, no problem.
Please.
No problem. No problem. I'm gonna send this to you in a class, but it's good to write in notes, not true?
Sure.
Yeah, man. Let me tell you something. So when you write your own notes, you remember it. But if you just have, like, if you're trying to study from a screen, it's quite rough. Okay, are you through? Was it?
Yes, thank you.
All right, no problem. All right, so we're looking at a 2 by 2 determinant of a 2 by 2 matrix. All right. Okay, now if A, let us define a matrix. If A is this matrix here, let's call this A, B, C, and D. All right, then the determinant of A is, all right, so there are two ways of determinant of asking this question here. All right, look here, guys. So there are two ways of denoting or representing a determinant. They can actually just state it like this, determinant of A, or this is a symbol that you use. It's like it's not a bracket. It's like A dash dash or slash slash or column column. All right. So this is how they denote determinant. All right. So either they state it like this, or you have it like that. All right. So basically, all right, before I even go there, so let me show you something. Let me just discuss something with you. Okay, we could call this a rectangle. Am I correct? That's
Yes,
a rectangle, right? So now, if I were to draw a line like that and draw another line like that, you see these two lines? It looks like Jamaica flag, not true? These two lines that cross the diagram, they're called diagonals. All right? What are they called, class? Diagonals. No, you see this diagonal here is called the leading diagonal. What is it called? The leading diagonal. And this one is a PNP. PNP is what?
Non-leading.
Non-leading. I hope I don't offend anybody. All right. So the one that slants to the left is called the what? The leading diagonal. The one that slants to the right is called the what? The non-leading diagonal. Now, if you notice that the matrix, it's like it have diagonals, not true? Look at it. Would you agree with me? Yes, it would appear as it has a diagonal just like this rectangle. All right. So oh boy, let me just get rid of this. So it's a formula. What we do is see, we multiply we find the product of the leading diagonal, which is A times D. Subtract, yes, it's always subtract, it's a formula. Subtract the product of the what? The non-leading diagonal. So it's a little formula. All right, class? Are we clear?
Sir, question. Some of these formulas are gonna be on the CXC paper, right?
No, this is not on it.
Okay.
Let me tell
But
it.
some of them are gonna be on it, right?
All right. Let me tell it from now. The formulas that are in CXC are the trigonometry formulas, the measurement formulas. That's mostly it. Those two sets.
Okay.
For example, so-called sine, cos, and tan. And if you want to find the area for a circle, the area for a cylinder, those formulas, they're given in the formula sheet. But for example, this, you're gonna have to remember it.
Okay.
All right.
So the quadratic formula is not gonna be there.
Yes, it is also be there. It's also going to be there.
Okay.
All right. So another way you could write is just AD subtract BC. All right. So any of those would work. So we're going to multiply the leading diagonal. So the leading diagonal would be 12. 12 times what? Times 2. Subtract.
5.
5 times 2 or 2 times 5. It doesn't really matter. It doesn't really matter. Which one you want to put first?
Anyone.
Anyone, because multiplication obeys the associative law. And that's what? 24 subtract what? 10? So the answer there is 14.
42.
That's the answer, sir?
Yep.
Okay. All right.
But be careful of these ones here. They're a little bit tricky. All right.
I have 2 negative 2 times negative 1
Well,
minus.
give me a minute there. Let me.
Okay.
So negative 2 times. And yes, continue.
Negative 2 times negative 1 minus 9 times 0. So that would be negative, like negative 2 times 2 would be 2. 9 times 0 is 0.
All right. So the answer is
2 minus 0, 2.
which is 2. Very good. Awesome. All right. Who wants to take on this one?
Sir, can I try? Okay. Leading diagonal 4 times 2 take away -1 times 1.
Mm-hmm.
4 2s 8.
Mm-hmm.
Take away -1 times 1 is -1.
Mm-hmm.
And then now 8 take away -1. 9.
Right. Plus 1.
Yes. So the two negative give you a plus.
Sorry. Yes. Okay. All right. Who wants to take on this one? The last one. Any
We can
takers?
try again.
Yes, man. All
Four,
views. Sure, no problem.
4 times -2. Take away 8 times -1. Mhm. 3 times -2 would give you a -8.
Mm-hmm.
Take away 8 times -1, give you a -8.
Mm-hmm.
So -8 take away -8. I have 0.
You keep on missing out the
Something
it's a
missing?
plus. No,
That would be negative.
you keep on missing out the saying not saying the plus. That's what I
All
wanted.
right.
That's
8.
what
All right.
yeah.
-8 plus 8.
Right. That's what I
Okay.
wanted to hear you say
So
because that's Mhm.
at 1 appear 8. At 8 and appear 8. So 0.
Very good.
Yes, sir.
I believe somebody was saying something. You want you,
Never mind. Sir.
okay. Any questions? All right. No. Oh boy, this. I'm trying to get these notes. Note if the determinant of a matrix is equal to 0, just like this one. All right. So if the determinant of a matrix is equal to 0, then the matrix is called a singular matrix. All right, make a note of that here. So if you find the determinant of a matrix, right, and it is equal to 0, then the matrix is called a what?
Singular.
Singular matrix. Otherwise, it's called a non-singular matrix. All right. So for example, these are what? Non-singular. All right. This one is also what? Non-singular. This one is also non-singular. But this one is what?
Singular matrix.
Singular. All right, class? We good?
Yes, sir.
All right. Before I go on, well, we're still gonna look at determinant of a matrix, right? But let us divert a little bit. All right. So this is we're just gonna digress a little bit. Digression. But it is connected to what we're doing. All right, point number 1. I'm gonna jog back your memory to solving equations. All right. Suppose I have something like this: 5d subtract 7 is equal to, say, I don't know, 13. Find d. How do you solve this? Anybody remembers?
You're gonna minus 13, put minus 13 on that, from 13 on that, the right hand side, sir.
No, you're not gonna do it.
Okay.
You But your train of thought is on the right path. You're not gonna subtract 13.
7.
You're gonna you want to get rid of 7 on the left hand side. So we're gonna add 7 on the left hand. But I understand what you're trying to say, but it's just the wrong thing.
Yes, it should be 7, sir. 7.
Right.
7 plus 7 and
So
then 13 minus 7.
No, no. If you're gonna add 7 on the left,
5D minus 7.
we're gonna add on the left.
So you're gonna add it on the right.
Right, we have to add it on the right. So then why is this thing? Alright, so it would have been well, this will go away, not sure. That will be 0.
And so it'll be 4. So.
Alright, and then we have 5, yes, that's correct, is equal to 20. And then we just divide everything. We divide everything
By 5.
by 5. Alright. So as you correctly said, P
4.
is 4. Alright? Everybody get that? Alright. Let's look at another type. Alright, so no, this one maybe. Alright, let us just play around with this and see how it goes. Alright. Suppose I have R multiplied by R. What is that?
R squared.
Right.
Squared.
R squared. Very good. Now, suppose I want to get rid of the square of the R. What would I do? Anybody knows?
Oh, I'm going back to there, sister. So get rid of this square.
Say it again.
No, we use it. We did. I'm just saying it's like a revision there. We're getting rid of the square.
Right. But yeah, okay. Oh, so what do we do to get rid of the square? We square root it.
Square root.
Oh. So if you square root, oh, look like this. If you square root a square, so for example, you have R square, the square will vanish, giving us what? R. All right? So make a note of that. If you have a square and you want to get rid of the square, what do? We square root. All right, so make a note of that. Look at this question. If P all right, hold on. Let me ask something. What's the answer for that? What's the square root of 25?
5.
5.
5, not true. Suppose I say you're half right. It's actually plus or minus 5. Why is that so? 5 times 5
Okay. Okay.
gives us what?
And
25.
25. And negative 5
Right.
times negative 5,
Still give it a 25.
25.
Very
Right.
good. Right. So that's why the square root of any number is always what? Plus or minus. All right. But we don't normally use a square. What do I want?
Values of P.
P. So, but this is not P. What is this? What is this? P2.
Square.
So what do I need to get rid of? The square.
It's square.
But what did I say up here, so? If you have a square,
Square
I want
root. Square root.
right. Thank you very much. We square rooted. All right. So that's what we're gonna do. So that's P square. But guess what? No. Isn't this an equation? So whatever I do on the left, I have to do what? It on the right. So if I square root the left, I have to square the right. All right. And then this is just P alone, not true, because it will vanish. Remember now, when you find the square root of P squared, you get P. And the square root of 100 is what?
10.
You're half right.
Negative or positive 10.
Right, with negative or positive 10. Notice the ways of finding the values, not true? All right. You guys follow these little things here?
Sir, what you going on to quadratics now, sir?
Oh man, we're doing matrices.
Oh.
What you love you
Show the positive and the negative.
no,
Negative.
But,
That's why I asked that.
but you learn it from algebra, not true?
Yes, sir.
Right. All right. Any questions about this?
So, sir, what you just said, the answer for that one there, the P square equal 100. What's that?
Plus or minus 10.
Okay.
Just like the square root of 25, it's not 5, it's actually plus or minus 5.
Okay.
All right, let's go back on track now. Let's because we're doing matrices, right? All right, so let's look at this question here. Let's try to answer this question now. Solution. All right, first of all, what do you notice? What type of matrix is this?
Singular.
It's a singular matrix. What does that mean?
gonna be 0?
What is going to be 0?
The answer.
No. What before you get answer, what is going to what do we find of the determinant to get 0 to be the answer? The determinant, not true. You follow? So if the determinant, if you can't say it is 0, I don't know what that means. If the determinant is equal to 0, then it's called a what? A singular matrix. Right. So the mere fact that this question says this matrix is a singular matrix, it means that the determinant of this matrix here is equal to what? 0. So what we need to do, we need to find the determinant of this matrix. All right, that's what we need to find. So the determinant how do we find determinant again? What do? We multiply the what?
Diagonal, something. The leading and the non-leading.
Right. We find the product of the leading diagonal, subtract the product of the what? The non-leading diagonal. And what's the leading diagonal?
4y.
Y.
Right. 4y times y.
That go before
Minus 8 times
8, right? Times 2.
So is that gonna give you a 4y square?
Very good. Yeah.
Oh.
So 4y times y is
y square.
4y square, which is equal to what? So sorry, subtract what? 16 equals what? Hold on, let me.
So sir, you're gonna
Not finish it. So you have to find the other something.
Hold on. So. All right. So what is all of this equal to?
0.
Right. 0. Because it is a what? Singular matrix. So this is also equal to what? 0. All right. How do I solve this?
Anything you do on the right, you do on the left.
Right. So what do I want? I want y. So I don't need negative 16. So what I'm going to do.
Add it on the next side.
Right. Very good. I'm going to add what?
16.
16 on the left.
16 on the right.
16 on the left. 16 on the right. And we know this is equal to what?
No.
0. Right? And what left back
4y square.
is 4y square equal to what? 16.
Divided
And
by
then, and then we divide everything by what?
4.
By 4.
4y squared.
So 4, 4. And these two 4 going to cancel, true?
Mm-hmm.
Yes.
So therefore,
It's equal to 4.
y square is equal to what? 4. Not true? Yeah, but we don't want y. We don't want y square. What do we want? We want y.
Mm-hmm.
So what's happening right here? What am I have to do to get? What I need to get rid of what?
Square root it.
Square.
And how we give a square?
Square root.
Thank you. We square root it. Not true?
Yes,
And
sir.
because it's an equation, if I square root on the left, I have to square it on the what?
Right.
The right.
Right.
All right. Very good. Anybody else? Anybody else? So that's what? Sorry, that's. Y square. And this is going to be plus or minus, not true? Yeah, man. Plus or minus square root of 4.
Oh, so you put before that first, sir?
No, you can put it before or after.
Okay.
So what's the answer?
Plus
Plus
or
or-
minus 2.
So that's the answer. All right. Now, what can you infer from the statement about the type of matrix this is? What type of matrix is this? Is it a singular? Thank you. Right, it's a non-singular. Why is it a non-singular?
Because you don't give a
Equal to
a
0.
It's not equal to 0. So they're telling that determinant of this is equal to -7. All right. So solution. Let's find.
And
Let's. Go ahead.
Oh, I was just gonna say it also does not state values. There's only one value.
Right. So there's no square and square root, and none of that is in this question. And also because well, if I could actually make it into that way, but I just decided not to do that. All right. So M. So what do? We multiply the what? The leading diagonal, not true. So it's 4. It's 4 times what? 5. Subtract what? 3.
3 times 3a.
3a.
So 20 minus 9a.
And that is equal to what? -7. Not true.
Yes, sir.
If it was singular, it would equal to what?
0.
Right. So all we need to solve this.
So it'll be 20 minus 9a. 7
Right. 20
minus 9a
90
equal -7.
equal -7. All right. What do we do here now? What do we solve this?
We're gonna find a, sir. So we're gonna determine what we're carrying over. So we're gonna bring over 20.
Bring over where top about?
Get rid of the 20.
You're gonna
Right.
get rid of it. So
Right.
remove,
We're gonna get rid of the what? 20.
so remove that same thing, sir.
No, we can't go that route right now. So to get rid of 20, what do? We just subtract 20, not true? And if I subtract 20 on the left,
Right.
I have to do it on the what? The right.
Subtract 20 on the right.
So that will go away. So what left back is -90. Am I correct? Equal -27. Is that so?
Yes, sir.
Yeah,
Yes.
man.
Put that over 9.
And let's divide everything by what? By 9.
-9.
Correct. It's actually -9.
+3, sir.
Right. So this 9, that cancel out. All right. So A is equal to +3. That's it. That's the value of A. Because negative here, this negative here, divided by that negative gives you a positive. And you can get 3 groups of 9 out of 27. So that's the answer. All right, so to find the inverse of a 2 by 2 matrix, we have to use a formula. All right. So this is a formula. So let us define a matrix. Let's say we have a matrix A. And A is A, sorry, A, B, C, D. All right. Then the inverse of A. No, another way of writing the inverse of A. So, or we could say A to the -1. So A to the -1 means what? The inverse of A. All right. Remember, it doesn't have to be A. It could be any letter. As a matter of fact, it doesn't have to be a letter. They don't have to say that A equal to. They could just give you a matrix and just ask to find the inverse. All right. So this is the formula. So the formula is it's 1 over the determinant of A multiply by the adjoint of A. All right. So no, would have covered what determinant is, not true? All right, class.
Yes, sir.
Right, but what is this? So this
Confused.
this is the formula, but what is that? So that's what we're gonna look at now. The adjoint of A. And when I say A, I'm talking about what? Matrix A. All right. So in other words, when it says 1 over the determinant of A, so for example, this is the determinant of matrix M here is -7. So 1 over, if I want to find the inverse of M, I'll have to start with what? 1 over -7. All right. So that's easy. So we're going to look at what we call the adjoint of A. Now, the adjoint of A is equal to listen carefully, right? You know what? I'm gonna write. You know what I realized? I always say this, but I never write it down. All right. So what we do is that we flip the leading diagonals, and we change the signs of the non-leading diagonal. Let's go right. Whoa, what the error is there? Sorry. All right. All right. Let me take this out first. So what is the adjoint of A? What do? We flip. The, well, I would probably say the element of the leading diagonal. Yeah. So therefore, this is what we have. Tell you what, let me put A beside it. All right, so that's A, and now we have adjoint of A. So the adjoint of A, what I say I'm going to do? Flip. Right. So the leading diagonal is what? A and D, right? Is that so?
Yes, sir.
That's a leading diagonal, and we're asked to flip them. All right. So in other words, I'm not gonna have A there. I'm gonna have what? D. I'm not gonna have
A.
Right. I'm not gonna have D down here, so, but I'm gonna have what? A. Everybody see that?
Yes, sir.
So we flip the leading diagonals and we change the signs of the non-leading diagonal. Now, class, did I say to flip the non-leading diagonal?
Sign.
Right.
Yes.
Right.
So it will be negative
B, negative C. That's it. That's adjoint of A. Suppose B was negative. The original A. B was negative. Then this would have been plus.
Right.
All right. Everybody see that? All right. Let's look at an example. If let's say L is this matrix there. find L to the -1. Or we could say just find the what? The inverse of L. All right, so that's our question, that's our example. So according to this formula here, all right. Step 1, we need to find what? What do we need to find first?
The leading diagonal.
We need to find the determinant of L. Not true? Yeah, because look at the formula. It says 1 divided by the what? Determinant. You know what? Let me put the word determinant because. All right. So we need to find the determinant first. Not true? All right. So that's step number 1. So. So determinant. Oh, I see what they're saying. You multiply the leading diagonal, which is right. And then we have 1 times 6. So 3 4 is 12. 1 6 6. 6 from 12. 6. So the determinant is equal to what? 6. So that's step 1. Find L. Step 2.
We find inverse also.
Right. We need to use the no. We need to find the adjoint.
That's what it
Adjoint of the matrix. Sorry. Or the adjoint of the matrix L. All right. So the adjoint of L well, this is the original matrix, not true?
Yes.
What step say to find the adjoint?
flip, sir.
We flip the leading diagonal. So we have 3 4. So I'm
So
gonna
we
have
have
what?
1
4 3.
4
And then we
and
have
change the sign
right. So that's gonna be -6,
to
negative.
-1. What do you think step 3 is? That's where we use the
Find
formula.
Inverse, sir.
Right. So we find the inverse using the formula. All right. And if you get a chance to study further math, you realize that this is one way of finding the inverse. All right. So we're going to use the formula. So I'm just going to state the formula. I'm just going to restate the formula here. All right. So yes.
No, I was just informed that I believe in class after you write this out.
Well, we're not done this out now. Class done.
Okay.
All right. So, well, it's not A.
It's L.
Right. So it's L and L. So,
Verse.
right.
Over L.
So L inverse is equal to 1 over determinant. Now, what's the determinant?
L.
6.
6. So it's 1 over 6. All right. Times the adjoint, which is this. You see that? But then no, we have to work out what we're going to multiply 1 over 6 times everything inside, and that will give us the what? The answer.
Yes.
So we're going to have times. Let me see if I can do a little bit of magic. Everybody see that? So it's 1 6 times everything inside the bracket. All right. All right. So let me tell you, I can tell it from today is that for next class, we're going to look at what we call equal matrices, and then we're going to look at how to use a matrix method to solve simultaneous, and we will finish the unit matrices next class. All right. So I believe the next class, I think next class we would be in May. Is that so?
Yes, sir.
No.
Or close to it? Not true. No, it wouldn't be in May.
No, the other class after next week.
Right. Because next week is the 28th. All right. So come May, we're going to look at vectors. All right. And after vectors,
Trigonometry.
no, we're going to look at statistics. Probably we're going to do a lot of graphs in May. So statistics, we're going to look at straight line graphs. We're going to look at curves. We're going to look at rotation, reflection, everything about graphs, speed time graph, linear programming. So for the entire month of May, we will look at graphs. Now, in June, or I think exam starts in the middle of June. So I guess for the first 2 weeks, we will look at geometry and trigonometry. All right. I would have posted some workshops that ministry will be putting on next week.
What if CXE was in May? What would we do, sir? Because we would have covered those topics, vectors and graph.
No.
With the graph thing.
Well, thankfully, we can't think about that, not true?
Right.
All right. So, well, it's.
If I can record this song.
No, I'm not hearing it so well.
Oh, this no, please. I work 4 o'clock in the morning.
So you're breaking up.
She said she has to work 2 o'clock in the morning. Work it out, sir. Some of us has to go to work early.
Oh. All right. So we're going to multiply 1 over 6 times 4. So 2 into 6 goes 3 for here. 2 into 4 goes 2. So that is what? 2 over 3. All right, 2 over 3. So that 2 into 4 goes 2, 2 into 6 goes 3. But when nothing else can cancel, you multiply across. So 2 ones 2, 3 ones 3. All right, and for this one, 6 and 6 goes 1, 6 and 6 goes 1. The 6 cancels 6 gives you negative 1. So that is just what? Negative 1. All right, for this one, 3 into 3 goes 1, but it is 1, and 3 into 6 goes what? 2. So at the bottom here. All right, so it's actually 1 over 2.
Go again, sir.
Hold on. All right, so
That one work out.
yeah, I'm working out this one. The one on the right.
Oh, some of them, I next some of them work out. Alright.
And this one here. Well, I mean, this is just 1 and this is just 6. So 1 times negative 1 is negative 1, and you're right about the 6. All right. Or if you want to, you can if you have a calculator, just convert it to a decimal, and you get the decimal equivalent. All right. But I don't like decimals. All right. And that's how you find the inverse of a 2 by 2 matrix.
Answer finished right there, sir?
Yes.
So, sir,
Mm-hmm.
you said so, sir, the 1 over 6 times the negative 1. You couldn't say negative 1 into 6. You couldn't do that, sir, right?
That's what I did. But negative 1 to 6 goes 6.
Right.
Well, let me tell you what I did. Just work out the sign first. The 1 over 6
Okay.
is positive, not true?
Right.
And this is negative. So positive. It's like you're working out say 4. So you're working out 4 times negative 3. All right. What you work out first? You work out the sign. So you say, okay, positive and a negative. Yeah, negative. 4 3 is 12. So it's just like this. A positive and a negative gives you a negative. And then 1 times 1, I mean, you get about 1 was, well, 1 times anything gives back the same thing, basically.
Understood.
All right. Okay, another last point, you see. Sometimes you can leave your answer like this. You see what I have here, sir, in highlight, in blue? You don't have to work out it all the time. But if I'm introducing it to you, I would want you to work it out. But I'm going to show you where there are times when you don't really, it's not necessary to multiply the 1 over things.